In this video, I'm going to be working the depth of the seawater question from the 2024 AP Calculus exam. So it says a depth of the seawater can be modeled by the function h that satisfies this differential equation. And then we're going to sketch the solution curve h of t on the slope field. All right, so we know that it goes through the point 0 and 4. So we're going to need to start our solution curve there. And otherwise, we're going to just kind of try to follow the lay of the land. And, you know, if you've got the thicker of a pen you've got, the better. The 3 marks that we need to hit on this pretty much is it needs to go through the point. It needs to extend to the edges of the slope field, or at least reasonably close, and it needs to not have any flagrant contradictions to the slope field. I don't love the way that it's interacting right here, where I just hit it with a little bit of highlighter, but it's not, I don't think, enough to, it's not a flagrant contradiction, so I would definitely get the point. In part B, it says that it can be shown that h of t is greater than 1, and we're going to find the value of t between 0 and 5 at which h has a critical point. Okay, well, maybe I'll just start with that. So a critical point would be where h prime is either equal to 0 or undefined. So it's going to be h prime of t equals 0. Okay, h prime of t, that's the same as dh dt. So I might say, okay, 1/2 h minus 1 times cosine of t divided by 2. Okay, that's going to need to equal 0. Okay, they told me that h is always greater than 1, so h minus 1 is always positive. So really the only thing that could be negative is this cosine. So I'm going to say, all right, I'm interested in where cosine of t divided by 2 equals 0. I'm going to think about a unit circle right here. Let's say, where is cosine equaling 0? Okay, here at pi over 2 and 3 pi over 2. Well, it just said there was 1, so I'm going to start with the idea of pi over 2. So t over 2 equals pi over 2. That makes sense. Okay, it's pretty easy to solve. T is going to need to equal pi. And 3 pi over 2 would not work because that would end up giving me t equals 3 pi, and that would be outside of the interval 0 to 5. Okay, now we're going to determine whether the critical point corresponds to a local maximum, a local minimum, or neither at that time. And we're going to justify our answer. Okay, well, if we're going to determine that, well, we already know the derivative is 0, and this is a differential equation, so we should probably just take the derivative to do the second derivative test. We're not going to be able to do it before or after. Actually, maybe we could, because knowing h is always greater than 1. Yeah, you could do some analysis on cosine. I'm not going to do that, though. I'm just going to take the second derivative. But I'm definitely not saying that if you did, made the remark that, okay, because h is greater than 1, 1/2 is always positive, h minus 1 is always positive, cosine of t divided by 2 is going from positive to negative at t equals pi. And so that would be positive to negative, that would be a maximum. Okay, that's what I'm expecting to get. But I'm going to take the second derivative, and that's going to be 1/2 of, first I'll take the derivative of h minus 1, and I'll leave the cosine the same. Okay, and then I will add 1/2 of h minus 1 times the derivative of cosine of t divided by 2, which is going to be 1/2 negative sine of t divided by 2. Okay, and then I will plug in t equals pi. Okay, we knew that dh dt was equaling 0 at t equals pi because that was what made it a critical point. So there's going to be 0 there, and so that whole term is going to go 0, plus 1/2 of h minus 1, which is going to be a positive number, times negative 1/2 times the sine of pi over 2, which is going to be 1. Okay. Sine of pi over 2 right there, thinking about the y coordinate, that's going to be 1. Okay, and so I've got 0 plus a half of a positive number times a negative number, that's going to be less than 0. Because it said justify my answer, I might say because h is greater than 1. Or h of pi is greater than 1. Okay, and so since I'm going to say maximum, and I think that would probably be good because we'd shown that h prime was 0 and the second derivative was negative. But, if I just want to have the best possible answer, that would be because dh dt at t equals pi is equal to 0, and also the second derivative of h with respect to t at t equals pi is negative. All right, and then part C is going to ask us to solve the differential equation using separation of variables. And this is one where, there's a lot of stuff going on in the differential equation, but if we just keep our cool, it's going to be all right. Okay, so I'm just going to get rid of everything with h, which would be that h minus 1, by dividing both sides by h minus 1. So 1 over h minus 1 dh is going to equal 1/2 cosine of t divided by 2 dt. And then I'm going to anti-differentiate both sides. Okay, and then on the left-hand side, I would get natural log of the absolute value of h minus 1. Now, because they told us that h was greater than 1, I don't think we would necessarily have to have the absolute values, but it's still going to be true. And then over here, when anti-differentiating 1/2 cosine of t divided by 2, I bet a lot of people are going to get knocked off the train here. I think, for people in my class, I think our best option is going to be, 1/2 sine of t over 2 is kind of like a hypothesis, but then we're going to think about the chain rule, and we'd probably need to divide by that half to prepare for the half coming out, and we'd realize, oh, this is just the derivative of sine of t divided by 2. Okay, so that's going to be just sine of t divided by 2. Take a second. Think about taking the derivative of this. I would get cosine of t over 2 times a half for the chain rule. Okay, so this is good. I'm going to add my plus c, and then I'll start solving for h. All right, get rid of the natural log, so the absolute value of h minus 1 is going to equal c e to the sine of t over 2. We know h of 0 equals 4. We could plug in 0 and 4 really at any point here to find the value of c, but I'm going to wait until I've solved for h. So h minus 1 equals plus or minus c e to the sine of t over 2. Then h itself is going to equal 1 plus or minus c e to the sine of t over 2. Okay, now they told us 0, 4, right? H of 0 equals 4. So h is going to equal 4. 1 plus 3. So I think c is going to need to equal 3. E to the sine 0, yes, e to the 0. And so c is going to equal 3. And so my solution is going to be h of t equals 1 plus 3 e to the sine of t divided by 2. And, we could put a box around it if we wanted, or we could just say that that's going to be, at the bottom of our work. That'll be all. Okay, so that's going to be all for this video. Thanks for watching.